Hi guys. Last class we discussed about the refrigeration, basic refrigeration and types of refrigeration systems used. And today it's a second lecture. You can just see the notation, that is M1L2, Module 1, Lecture 2. And now I'm going to discuss a few basic points from your previous semesters, which is very useful and which is very important to do the problems and also to understand the basics of the refrigeration. So, actually, my heading is properties of substance. Actually, it is very suitable if we use properties of any substance. So, we just see it is. I'm saying about any substance. Okay. First thing is temperature. Don't feel bad. I am just giving all these things once again in your fourth year. It is very important that if you go to an interview, maybe that guy who is asking you the questions will question you about what is temperature. So just I will recollect all these things and feed it in your mind. First thing is temperature. So what is temperature? Actually, temperature is degree of hotness or coldness of a body. It is usually denoted by T, and the units of temperature is Kelvin, degree Celsius or degree Fahrenheit. Okay, these are the three units. Now the second one is heat. See, heat is the amount of energy flow between a boundary due to difference in temperature. See, actually, see here you can see a line, a boundary, and also there is a difference in temperature. So is there any mass flow between that boundary? See, answer is no. Mass is not flowing across that boundaries. So that is heat. It is usually denoted as Q. Okay, and heat has the units, and it is basically measured in the quantity joules or kilojoules. Okay, now next thing, important thing, that is sensible heat. See, sensible heat is the increase in temperature when heat is added. So I will give another definition, that is the increase in temperature when heat is added, which can be sensed. See, which can be sensed. Sensible. See that spelling, sensible. So it can be easily related with sense. So example, you have a body temperature of 32 degrees Celsius. Let us assume that you have a body temperature of 32 degrees Celsius. So when you have a fever, the body temperature will increase a little or maybe more. Suppose you have a 36 degrees Celsius of temperature now. You just ask your mom to check whether you have fever. She will just put her hand in your forehead and tell, oh, it's a bit temperature over there, so it is I think you are having fever. So actually, how she assumed that you are having fever, that is, she sensed the heat. Similarly, sensible heat is the heat which can be sensed. So it will make an increase in temperature when heat is added. The next thing is latent heat. See, latent heat has another meaning called as hidden heat. Hidden. Okay, hidden, HIDDN, hidden heat. That is, this heat can't be measured by using a thermometer. Okay, to measure a temperature change, you have to have a thermometer. So latent heat can't be measured by a thermometer. That is why it is called as hidden heat or latent heat. Actually, this heat brings a change in state, but no change in temperature. Actually, how it brings us change in state? See, it is one more thing I have to mention. The sensible heat is denoted by HF. Very important, H suffix F. Okay, sensible heat is denoted by H suffix F. Actually, that F is for fluid, the sensible heat of fluid. So we are dealing with fluids. Okay, the next thing is latent heat. So I have given enough explanation for latent heat. It is denoted by HFG. HFG means, actually, HFG means the fluid is converting it into gas. The fluid itself is converting into gas by as absorbing an amount of temperature. So that amount of temperature can't be measured by a thermometer. So that is called latent heat. Actually, there are two types of latent heat. First one is latent heat of fusion, and second one is latent heat of vaporization. First of all, I will say what is latent heat of fusion. That means for 1 kilogram of ice, or say m kilogram of ice, have to absorb 335 kilojoules of heat to convert it into water at same degree Celsius. Or you can also say that the ice at 0 degrees Celsius is converted to water at 0 degrees Celsius by absorbing 335 kilojoule for 1 kilogram. Okay, similarly, what you can say for latent heat of vaporization, that is a 1 kilogram of water at 100 degrees Celsius can be converted to steam by absorbing 2257 kilojoule for 1 kilogram. Okay, so that is latent heat of fusion and latent heat of vaporization. See, one thing you have to clearly know that these two latent heats are at a single temperature. See, latent heat of fusion, both states of water is at 0 degrees Celsius. So there is no change in temperature. Also, at the latent heat of vaporization, the both state of water, that is water and steam, both exist in 100 degrees Celsius. So there is no change in temperature in there also. So that is latent heat of vaporization. The next thing is specific heat. See, specific heat is the amount of heat required to raise the temperature of a unit mass of any substance through 1 degree. See, simply you can denote it as C, small letter c, and it can be easily said that so for 1 kilogram of any substance is increasing the heat of itself for 1 degree Celsius or 1 Kelvin by absorbing a particular amount of energy. So that is kilojoule per kilogram Kelvin. So unit is expressed in kilojoule per kilogram Kelvin. See, this specific heat gives light to the basic equation Q is equal to mc delta T. See, initially the substance is at T1, and when we supply more heat, the temperature will increase to T2. If the specific heat is C and the mass of the material or substance is m, then the net heat supplied Q is equal to mc delta T, that is mc into T2 minus T1 kilojoules. So that is specific heat. Now the sixth one is enthalpy. See, enthalpy is the sum of internal energy. Internal energy is denoted as U, and the product of pressure. Pressure is denoted as P, small letter p, and volume. Volume is also denoted by V. Okay, so the total enthalpy is denoted by small letter h, that is U plus PV. See, consider initial condition H1 is equal to U1 plus P1 plus U1 plus P1 into P2. P1 into V1, and for the second final conditions, H2 is equal to U2 plus P2 V2. So the net heat supplied in here is H2 minus H1, or delta H. Okay, delta H. So that is enthalpy. So this is a basic and important equation for the problems. Now the next one is entropy. See, entropy is just simply the degree of disorder in a system or the transformation of enthalpy. I know that you have not understood the meaning of this sentence. See, degree of disorder, I will just say an example. See, you have a nozzle or a pipe. That pipe you are giving steam at 130 degrees Celsius through that pipe at one end. That is in metallic tube, and at the end of the also at the other end, you can feel the temperature of the steam as 125 degrees Celsius. So you have noticed that there is a change in 5 degrees Celsius. So where is this heat lost? Actually, that is the measure. That 5 degrees Celsius is the entropy. So this 5 degrees Celsius actually lost for the transfer of that heat energy from one end to the another end. This the measure of this disorder is, or the transformation of energy is called as entropy. It is simply denoted by S, and unit is given by kilojoule per kilogram. See, kilojoule per kilogram, and it gives the basic equation in thermodynamics, that is dq is equal to TdS. That is, dq is the small change in energy, or the small change in enthalpy, and ds be the change in entropy, and T be the temperature of the system at which this dq is measured. Okay, now the last point you have to know is the dryness fraction. Dryness fraction is measured as x, small letter x. So consider a vessel having m water. See, it's actually it's a suffix. Okay, m water, m water amount of water, and m vapor amount of vapor. How it is possible? First of all, it doesn't have any vapor, so you have to give heat energy. This is the heat energy you are giving. So water is transformed into vapor. So you know there is a small amount of say x or a amount of vapor, and you have b amount of water remaining in that vessel after some time. Now the formula of dryness fraction is x is equal to m vapor divided by m vapor plus m water, that is mass of vapor divided by mass of vapor plus mass of water remaining in that vessel. Okay, or you can also say that this is the mass of dry steam. This is the mass of dry steam divided by this is the mass of wet steam. Okay, wet steam plus moisture, or wet steam, simply wet steam. Okay, so that is x, that is mass of vapor divided by mass of vapor plus mass of water remaining in the vessel. Now consider, for example, for your ease of understanding, I'll just give an example. See, we have 100% of water initially, and it is vaporized to 100% of vapor. That is, suppose you have 100 liters of water, it is vaporized to 100 liters of vapor. Okay, so we can substitute the mass of water, mass of vapor as 100 and 100 liters, and now mass of vapor in denominator also 100 plus the mass of water. There is no remaining water, so it is 0. So answer is 1. If the x value is 1, then it is called as dry steam. Very important. Okay, when x value is 1, that is called as dry steam. Now consider another condition. See, initially we had 100 liters of water, and the 90 percentage or 90 liters of water is transformed into steam. So remaining water is 10. Okay, so we can just substitute it as 90 liters divided by 90 plus 10. So that is 90 by 100, that is 0.9. So it is called as wet steam. If the amount of x value is less than 1, then it is called as wet steam. If x is equal to 1, then it is dry steam. Now we know HF1 is the enthalpy of, the HF1 is the sensible heat, and HFG be the latent heat. Then you have to know this equation. This is very important. That is, H1 is equal to the net enthalpy. H1 is equal to SHF1 plus X1 into HFG1. Similarly, can also give us S1 is equal to SF1. S1 is the entropy at point 1 is equal to the sensible entropy at point 1 plus X1 into the latent entropy at point 1. So we can give this condition for any number of conditions. Okay, so this is very important relationship. You have to know all these things. I have mentioned several things that starting from the bottom: dryness fraction, entropy, enthalpy, specific heat, latent heat, sensible heat, heat temperature. These much thing you have to know definitely for doing the problems. So hope you understand all these things. Just go through the video and come for the class. Thank you.